All right, so let's go ahead and check out these other two on page 63. We were discussing the intermediate value theorem, which had two conditions. Okay, those two conditions had to be met in order for us to be guaranteed some value. So let's go ahead and kind of refresh on memory. What on earth does the intermediate value theorem mean? What does it tell us? Maybe what are those conditions? What are we finding? Anything like that. Okay, can we dig deep from yesterday? Anything that you remember about the intermediate value theorem from yesterday? Yeah.
The intermediate value that you're trying to find, such as f of c and using the problem we did yesterday, 2 over 3, the leftmost x value and the rightmost x value, their y values, the one that you're trying to find has to be somewhere in between.
Okay, so that's one of our conditions. I think we listed that as the second condition. The y value you're trying to evaluate or focus on should be between the y values or outputs from the interval. So the y value you are using or focusing on must be between the y values from the interval. And we normally use a and b to represent the beginning interval point and the ending interval point. Okay. Garrett, can you do me a favor and shut the door? Okay, so that was our first condition. So far so good. Maybe we can determine the first condition we need. What are we trying to find? Go ahead, Stevie. Has to be continuous within the interval. Okay, so f of x is continuous. You should be able to draw it without lifting up your pencil. Okay, that informal definition. So f of x is continuous on the interval. Good. So if those two conditions are met, okay, you can draw the graph without lifting up your pencil, and a specific y value between the y values of the interval, what are you then guaranteed? Or what are you then able to find or determine? So if you think about your science classes, you know, like those if-then statements, like hypothesis, conclusion type stuff, okay? These two conditions are your if statements. If these are true, then what? What's your conclusion? Go ahead, Dan.
Then there exists at least one value, x equals c, between a and b, such that f of c is y.
Okay, so there is some number between a and b, whatever your beginning interval value is and the ending interval value. There's some number in between there that if you were to plug it into the function, okay, for instance, f of c, if you were to take that number and plug it into the function, you would get out that y value that you kind of started with between the y values from the endpoints. Okay, you are guaranteed at least one of those values of c. There might be more than one. There might be more than one x value that gives you the same y value, aka height. Okay, but we are guaranteed that. There's at least one. And if there is at least one, maybe we can try to find it. Okay, that's what we did in the last example from yesterday, and we're going to pick up with these two from today. So before we even jump to this conclusion, we have to make sure the hypothesis or kind of if statements are true. So let's go ahead and take a look at number 4. They give us the function, they give us the interval, and they give us that y value that we're trying to see is in between the y values from the endpoints. Okay, so let's go ahead and check out our first condition. Is the function continuous on the interval? So you got to think about, if you were to graph that equation, would you have any jumps, asymptotes, or holes? Can we think about it? Always be careful with a fraction because things can go wrong with those. What do do you think? Is there some value for x that if we plugged into the function would cause some type of issue, aka whole jump asymptote? What do you think, Ryan? 2. Okay, so x equals 2. If we were to plug in 2 into the function, we would get 2 over 0, which is representing a number over 0, aka vertical asymptote. So x equals 2 is a vertical asymptote. So that is a point or location of discontinuity, but are we concerned with that location? Is our interval including that value of 2? No, because 2 is not between -1 and +1. So even though there is an issue, okay, there is a vertical asymptote, it's not an issue for us because we're only focusing on that interval. So we can say f of x is continuous on the interval. So we satisfy the first condition. We're continuous on the little section of graph that we're checking. Okay. The second criteria is that this y value of -1/2 shows up in between the y values from the interval. So we're going to have to plug in the interval values of -1 and +1 to get their heights. So if you plug in -1, we'll have -1 over -3, which is +1/3. And if you plug in +1, we'll have 1 over -1, which is -1. So is our second condition met? Is the y value of -1/2 that we're interested in between the y values from the interval? Yes. Okay, so -1/2 is between 1/3 and -1. So our two criteria are met, which means we are guaranteed some x value between -1 and 1, such that if we were to plug that into the equation, we would get -1/2 as our answer. Okay, so we are guaranteed at least one value. What we're going to try to do is actually find it. Okay, so we can say the intermediate value theorem does apply. I think yesterday I mentioned something about this being an existence theorem, right? Does that sound familiar? Okay, so the intermediate value theorem only tells you that there is a number out there. Okay, not necessarily that you have to find it. It's just telling you that there is one. I'm making you find it. Okay, so you can be mad at me for that. But the intermediate value theorem just says that there's something out there. Okay, but I want you to find that. So how might we, now that we know that IVT applies, how can we maybe set up an equation to help us figure out that special x value between -1 and +1? Can we have some type of setup? Let's see, we're trying to figure out which x value can we plug into the equation that would result in a y value of -1/2 specifically, right? Yeah. There we go. We're going to plug in the -1/2 for y, and we're going to solve for x. Maybe we get one x solution, maybe we get 2, maybe we get 5, who knows? We know there's at least one, okay, but we're going to see if there's any other ones. So there's our setup to actually find this special value or values. Where do you want to go from there to help you solve for x? So this is where kind of algebra comes in. What do you feel like doing with the way that looks? What are some techniques you can try? I mean, there's a lot of different things, so I just don't want to show one on the board. I want to see what you guys notice or want to do first. Maybe we'll start with the fact that we have two fractions equal to each other. Is there something we can do when two fractions are equal to each other? Yeah? That's if you're adding fractions. If you're adding two fractions, you need a common denominator. What if two fractions are equal to each other? Yeah. You cross multiply. Okay, I remember, I'll never forget this. My elementary or middle school teacher, whoever he or she was, always referred to cross multiplication as the butterfly effect. Because if you actually draw out the cross multiplication and draw in the little antennas, okay, it's the butterfly effect. And you always wanted to make sure there was an equal sign in the middle of the butterfly. That's when you could do it. Not sure if that helps, okay? But if we cross multiply, we'll have 2x, and then the other cross, we need x and the -2 being multiplied by -1. So you kind of have that distribution to do. Whenever you cross multiply, that's actually getting rid of the two fractions, which is nice. Alright, so from there we can solve for x. We can start to combine some like terms, maybe add over the -1x, and then divide by 3. Is 2/3 within our interval? -1 to 1? Yeah. So that's the special value. That's the location you are guaranteed to have, that if you were to plug that into the function for x, you would get out -1/2. Okay, you are guaranteed that location. Are we doing okay? All right, let's try the other one. So they give us the function, the interval, and that specific y value or output we're interested in. Let's go ahead and check to see if we can actually use the intermediate value theorem. Are we guaranteed a value? So if you think about graphing the function, would you have any holes, jumps, or asymptotes? Maybe think about what kind of function you have. What do you guys see, or what do you think? Yeah.
It's continuous.
How do you know?
It's an exponential graph.
It's an exponential graph. Okay, we covered exponentials last week, specifically looking at their limits. And exponentials, we said, are either growth or decay graphs in some capacity. I mean, these are just two examples, but when we did some reflections, we got different types of graphs. Okay, but an exponential function is always continuous. You can draw it without lifting up your pencil. So we can say f of x is continuous on the interval so our first criteria is met. Let's check out the second one. We got to make sure that -4 is in between the y values from the interval endpoints. So let's go ahead and plug in 3, and we'll plug in 5. Let's see, if we plug in 3, -3 plus 3 is 0. 1/2 to the 0 power is 1. We have the negative out front, which changes it to a -1, and then we are subtracting 2. So it looks like we get -3 for that first output. Next, if we plug in 5, let's see, we'll have -1/2 to the -2nd power. This one's going to be a little bit more work here. Instead of having a negative power, we can reciprocate the base, flip it, and that would make the power positive. So 2 squared, we got 4, and then -4 minus 2, we got -6. So is our second criteria met? Is the y value of -4 between -3 and -6? Checks out. Okay, so we can say -4 is between -3 and -6. So we are guaranteed at least one value that we can plug into this function that would give us negative 4. So the IVT applies. Okay. I'm making you guys do a little bit more work. I want you to actually find it. Okay, so let's see. Let's go ahead and set the equation equal to that y value we want as an output. And we gotta solve for x. What do you guys feel like doing? I know we talked about graphing yesterday, right? Where we did the intersection points. You could do that if you had a calculator, but this one we should be able to do without one. What do you want to do?
Add the 4 to the negative 4.
You mean add the 2 to the
Yeah,
negative?
yeah.
Okay.
Yes, add the 2 to the negative.
That's okay. Sometimes I'm a mind reader. Okay, so we'll move the 2 over. You want to continue? Yeah?
Yes, take the negative in front of the 1/2 and divide both sides, giving you what you're writing and the 2.
Positive 2, good. Okay, so we'll move the negative over, and this is when it gets good. You cannot move the 3 or the negative because they are in the power position. They're kind of being held captive up there in that little spot. So the only thing you can move over is the base of a half. If you move over a base, what does it become on the other side? Yeah, a log. Good. So this is a log with a base of a half. And inside that log is that number 2 that was on the other side already. So since we moved over the base of a half, we are now just left with that power stuff, negative x plus 3. If you move a base, it becomes a log. If you move a log, it becomes a base. Okay, those are the inverses. Okay, let's see if we can think about this. Logs represent powers, okay, exponents. So what power do we have to raise 1/2 to get 2? It's a little tricky to think about. What power do you have to raise 1/2 to get 2? Yeah? Negative 1. Okay? Negative 1. So this is now going to work out nice for us to solve for x. We can subtract the 3 over and then divide the negative. So our guaranteed location, we can plug in 4 into the function and it would give us negative 4. Notice how the x value of 4 we found is in the interval from 3 to 5, just like it should be. You are guaranteed a number in the interval that you could plug in and would give you that specific y value. We doing okay? All right. So that's it for the intermediate value theorem. There's not much to it, okay? We just need to be familiar with those 2 conditions, okay? They have to be met, and if they are, you could figure out the value if needed, either by hand or with the calculator intersection point that we did yesterday, okay? So in terms of your homework, if you haven't started already, you can do it, start it right now. We have a lot of time left. But it's going to go through asking you, does it apply? And in some instances, I'm going to ask you to actually find the value if it does. Okay, so just be sure to read the directions. Okay, you can use this time to work on the homework. You can use this time to help prepare yourself for the partner quiz tomorrow. If you want to go back and look at other things or other homeworks, that's fine. If you want to meet up with your partner and maybe discuss a game plan, okay, you could do that as well. But we have like a good 20 or 25 minutes. Okay, so you can consider this review time. All right.